For nearly their first 25 years of model train production, Rivarossi's signature motor design had a wide-diameter 3-pole flat armature supported by ball bearings and surrounded by a square field magnet. Now, although these were a bit noisier than many of the other motors of the day due to their unique sound profile caused by the ball bearings, they were efficient runners which were exceptionally smooth when tuned properly and can be found in most of their models from the small to large, steam, diesel, and electric. This particular motor here is the late version ball bearing motor, which was produced from the early 60s to the early 70s and powered most of Rivarossi's models during that time from the small to the large. This motor was in terrible shape when I got it and not in working condition, so I did a full restoration on it, and for this video I thought it would be fun to show you the full teardown of just how these motors are built. To start out, let's look at the center of the motor, which is the armature. So this here is the unwound core, which is made up of steel or iron plates that are stacked and held together by some pins going through. There's a plastic surrounding piece to insulate it from possible short circuits with copper magnetic coils. And this has a flat 3-pole design, wide diameter. And then that is pressed onto this unique shaft here, which most motors will just have a simple straight shaft going through, but these ball bearing motors have a stepped design which help it to interact with the ball bearings at each end. So there's a very small shaft here to provide as little resistance as possible. A larger one here which helps to hold things more balanced and give it more strength, since going this way you would get to the, in this case it would have a worm attached, but other motors would also have maybe a flattened end of the shaft to have a drive shaft coming out, or a separate drive shaft. Now, as for the windings, those are made up of 32 gauge copper wire, and there will be 300 turns on each of these pulls. So if you'll give me just a moment, I will go ahead and put those on now. And now there's a fully wound armature. Of course, before that can work, it's also going to need the commutator, which on this motor is made up of 3 plates that are attached to a high temperature plastic base. And this presses on to the top of the armature, making sure that each plate goes between 2 poles. If it's in any other position, the motor will not work correctly. That needs to be pressed on a little more than that, so I'll have to use some tools to do that. But once that is pressed on, I'll be able to take up the ends of the magnet wire here and solder them to the plates. And now there's the completed armature with the wires all soldered to the commutator. And that should be all ready to go. So now we can look at the rest of the parts of this motor. So next up is the base plate of the motor, which has the larger ball race in it. So this is just a metal plate here, and you can see that inside of that ball race it has kind of a rounded shape, and then the hole is just slightly oversized from the shaft to make sure that it makes no actual contact with the shaft while the motor's running. And then for the other main part of the motor, you have the plastic body here, which has the 2 brush holders built in, as well as the brush springs. It also has a ball race in it, which is smaller than the other one. And again, you can see that it has a rounded shape. There's also a small pinhole in there, which allows a little bit of oil to get in whenever it's needed. And in addition to that, you can see that there's a nut on the end here, as well as a nut right there. So in order to adjust the ball bearings, if ever needed, because these need absolute precision to run exactly right, you can loosen that nut that's on the body and then either loosen or tighten this one here, which will adjust this part in here to put more or less pressure onto those ball bearings. Then once it's perfectly adjusted, you retighten that small nut on the body. And now, of course, the main component of the ball bearing system is the ball bearings themselves. So these here are 1 millimeter in diameter, and I believe that 18 total fit into the motor, with 12 of them in this plate, and then 6 of them in the top bearing. And then next up, you have the 2 field magnet plates, which are not magnetic themselves, but they are made of blackened steel, which is the blackening keeps it from corroding, and then the steel helps to direct the magnetic field from the bar magnet right here, which fits into the top area of the motor right here, just away from the armature. And then, of course, to get power to the armature from the springs, you have the brushes. Now, Rivarossi on these motors, they always used 1 carbon and 1 metal brush. So the metal brush gives more electrical current to the commutator while scrubbing it clean, and the carbon brush helps to lubricate it a little bit to help things last longer. And then, just for electrical contact, they have this little contact plate here, which attaches to one of the screw holes and touches the corresponding brush plate or brush holder. Then to hold it all together, you've got these 2 screws right here. And now, with all that laid out, we can get this motor put together and see how it runs. Now, if there's one thing about working on these motors is that it is extremely tedious to get the ball bearings in place. So what I'm going to do first is spread just a little bit of grease through the ball race, and this should help to kind of hold the ball bearings in there while I place each one. And then, of course, with the grease already in there, I won't have to add any later. Now, of course, normally in motor bearings, you would want to have a light oil. But since these are different from the normal shaft and sleeve, it's perfectly fine to have some grease instead of oil. And now for the other ball race. All right. And now those are prepared to place the actual bearings inside. Now to place the bearings, you want to have some non-magnetic tweezers to carefully grip each one and drop it in place. So like I said before, the top one here gets 6. So I'll start with that. And there's one side with all the bearings placed. So just gently set that down and get to work on the other one. And also, just in case the ball bearings don't quite drop into place, you can use something like a small brass wire to kind of push them around a little and get them lined up exactly where they need to be. And now there's the other one, and it actually fit 11 bearings instead of 12. So now I'm just going to put the armature in there real quick to make sure that is actually the correct number. Feels like it's rotating freely. So the next thing I need to do is place the field plates into here. These have tabs on the top and bottom, and it's a mirrored design, so it doesn't really matter which way you get them in there or which side you get them on. All you have to do is get the tabs where they need to be. Now, holding on to that, I just need to carefully line things up. Snap it together and get one of these screws into here. Okay, that is tight. It's not working perfectly smooth yet, so I'll go ahead and put the other screw in. I'll have to take this one back out in a little bit so that I can get that contact plate in there. For now, I just want to make sure that this will turn smoothly. See, that's pretty stiff right now. Okay, so it turns out I just had one bearing too many in the bottom. It's supposed to be 10 and not 11. So now you can see here that it's spinning extremely freely, but there's actually just a little bit of play in there, which you don't really want. So what I'm going to do now is using a 3mm nut driver here, and turn that just a tiny bit at a time until it's turning exactly the way that I want. That's feeling about right now. So it turns freely. There's just the tiniest bit of resistance in there because you don't want it to be loose. Of course, you don't want it to be too tight either, so it is just the finest adjustment. Now that that's done, I'll turn this nut back to where it needs to be. Okay, that should hold it tight. Now, to put the magnet into the top. Just stick that into there. All right. Now before I put the brushes back in, might as well get that little contact plate into place. Okay, get this in here. Bend this down into here. So now it's got some tension for electrical contact. Retighten that. So now this brush is grounded to the metal plate. All right, now the last thing is to get the brushes in. So I'll just take that spring out from there. Start with the carbon brush on this side. Get that spring back in. Fits into the little hole in the brush. Okay, and there is a fully assembled Rivarossi ball bearing motor. And now the final step is just testing it out, and off it goes. My windings aren't perfect, there's a little bit of vibration from it, but that is running just about as well as the stock factory motor. So, those are the insides of a Rivarossi ball bearing motor, as well as how to put it back together. And this is certainly not a project that I would recommend for most people to attempt, but if you have the skill and the patience to fix one of these, then it is very possible to restore one into a near perfect runner.